Hello chemistry class. I just want to make a quick video so that you have something to refer to when balancing redox reactions, so you have something to look at and practice and help you as you prepare for the upcoming chapter exam. Let's take a little time and look at balancing redox reactions. These problems actually are going to take care of assigning oxidation numbers, writing half reactions, talking about oxidation, reduction, and then balancing equations, balancing charge, balancing the elements, everything. Everything is incorporated in these one problem. So if you can follow everything that we're going to do here in this short video, then you'll be okay for the exam time. Okay? All right, I'm going to do one or two for you, and then you can pause the video and do some of the others that are very similar to what I do. Okay, so I'm going to do let's look at this is number 5 on your worksheet, and I'm going to do letter C. All right, notice what it says here, that this is in an acidic solution, so remember that means that we have H plus and water at our disposal in order to correctly balance these. You first are going to assign oxidation numbers. So using the rules for oxidation numbers, you are going to assign a number for each atom of each element in this equation. So H is a +1, oxygen is a -2, -2, and remember, we don't know the carbon here, so all of these oxidation numbers in the formula have to add up to the charge on this particular unit, this particular molecule. There's no charge on it, so they all have to add up to 0. So 1, -2, -2, +1, and the unknown carbon all have to add up to 0. So that's going to end up making, let's see, that's -4. I think that's going to be a +2 on the carbon. Okay? Oxygen is a -2, each oxygen. And that means there's a little negative here. It's really hard to see, but there's a little negative. That's the charge on the entire unit of that MnO4. Each oxygen is a -2. There are 4 of them, so that's a -8. Plus the Mn have to add up to -1. So it's going to be a +7 on the Mn. Over here, CO2, each oxygen is -2. There are 2 of them, so that's a -4. Carbon must be a +4 to give you a neutral compound there. If you've got a monatomic ion, in this case Mn2+, the charge is going to be the same as the oxidation number is going to be the same as the charge on that monatomic ion. Okay, so we've assigned it. Now we have to identify who's being oxidized, who's being reduced. It looks like the carbon is going from 2 up to 4, so it is being oxidized. I'm going to put it over here in the oxidation side. And the Mn is going from 7 down to 2, so it looks like it is being reduced. So I'm going to put that on the reduction side over here. Okay? I'm going to take the parts in here that have my carbon, which is being reduced, and I'm going to take the parts that have the Mn, that's being oxidized, or that's being reduced. Over here it's being oxidized, sorry. Okay? Now we're going to balance each one of them separately. We're going to balance the elements separately, and then we're going to balance the charges. So I'm going to balance all the elements in each of these half reactions, except for oxygen and hydrogen. I leave oxygen and hydrogen until last. So I look at this and I see that I do have a carbon on both sides, so that's all taken care of. And I'm going to do my oxygen next. I have 2 oxygens on the left, 2 on the right. That's taken care of. So my hydrogen, I have 2 hydrogens on the left, so I need 2 hydrogens on the right. I balance hydrogens with H+. Over here, reduction. I have an Mn on both sides, so that's all taken care of. I have 4 oxygens on the left, I need 4 on the right, so +4 waters. Then I just brought in these 4 waters, which have 2 H's each, 4 of them, that's 8 H's. I have to balance that with 8 H pluses on this side. Now I'm going to balance charge. So I look at charge over here in the oxidation side. The total charge on the left is 0. The total charge on the right is a +1. So I bring that +1 down to match the total charge on the left by adding 1 negative electron. Over here, the reduction on the left, I've got 8 pluses and a negative, so it's a +7. Over here, I've got a total of +2, so I have to bring down this +7 down to the 2 by adding 5 electrons. All right, now the last thing you want to do before combining these two half reactions is to make sure that you're conserving the electrons. You can't lose 1 and then gain 5. Well, the way we fix that is we multiply one or both of the equations by a factor. So what we're really saying is we need 5 of these. We need to multiply this entire equation here, over here on the oxidation side, by 5 so that I have 5 electrons lost and then 5 electrons gained. So I multiply everything here on this side by 5. That assures me that I then have the correct coefficients so that charge is balanced. Now I'm just going to bring these two half reactions together. I don't need the electrons in my equation because there's going to be 5 on the right, 5 on the left, so that'll cancel. I also look for other things to cancel, things that are redundant. For example, I've got 5 H's on the right here, 8 on the left over here. So I know that these 5 are going to cancel 5 of those, leaving just 3. So my final reaction is going to be I'm just adding all of the reactants from both half reactions. I got this, I got my H plus MnO4, and then my products are okay. Hope I didn't forget anything there. Looks like I got that. I got that, I got that, I got that, and that. Okay, so that should be my final balanced redox reaction after all of those steps. All right, so you can pause the video right now and you're going to do D, and then you can check with each other in class to make sure you've got D correctly, and then I will provide the answer here in just a little bit. Okay? Okay, I am also going to show you how you are going to balance a redox reaction if it says it's in basic solution. So if it says it's in basic solution, we do everything the same, except there's just one little step at the end in order to kind of make a correction for the fact that it's in basic solution. So if it says it's in basic solution, that means we've got hydroxide available to us and water. Okay? So with hydroxide and water, we actually aren't going to introduce the hydroxide until the end. So we do everything exactly the same way that we've been doing it, but then we're going to do the hydroxide. We're going to take care of that at the end. All right? All right. So let's look at a redox reaction when we have a basic solution. Again, assign oxidation numbers is always your first step. And we have here O is a -2, H is a +1. And you'll notice here this OH, a -2 and a +1 is a -1, and you got 3 of them. So this CR must be a +3. Okay? And the Br, it's an element all by itself, no charge on it, so it's 0. The Cr and 4 O's, each O is a -2, that's -8. So this Cr must be a 6 in order to give you a total of -2 charge on that. The Br, there's a little negative charge on that. I know it's hard to see, but that's a -1. So it looks like the Cr is going from 3 up to 6. And the Br is going from 0 down to -1. So the Cr is going up. That's going to be our oxidation. I'm going to write everything that has a Cr in it over here. And then my reduction is going to be with the BR. Okay, now I'm going to balance all the elements, leave oxygen and then hydrogen till last, and then balance charge. So we have Cr on both sides, that's already balanced. We have 3 oxygens. I've got 4 oxygens over here. 4 oxygens on the right, only 3 on the right, on the left, so I'm going to add a water. And then that gives me a total of what, 5 waters, if I've done this correctly. So 5 waters. There's 3 here in this formula, and then 4. Oh, it looks like that's, yeah. So I brought in, okay. So I got three oxygens, and then this one is 4. Okay, I'm good. Now I've got 3 hydrogens, and the 2 hydrogens there is a total of 5. So I'm going to add the 5 H pluses over here to balance that. Okay, the BRs, all I have to do here is just put a 2 in front of this BR to balance it. There's no oxygen, there's no hydrogen, so that's all good. Now I just have to balance charge. Over on this side, I've got a total of 0 on the left here in the oxidation. Over on this side, I've got a total of -2 and +5, so that's +3. I'm going to bring this down with 3 negative electrons. Charge on this side, it's a total of -2. 2 times the -1 here. 2 negatives and 0 on the left, so I've got to match this by adding 2 electrons over here. Now we have to conserve electrons. There are 3 here, 2 over there. You can't have 2 different amounts lost and then gained. So I got to multiply this entire equation, the oxidation, everything by 2, the reduction, everything by 3. So everything here gets multiplied by 2 times 2 times 2 times 2. That's going to be a 10 now. Times 2, that's a 6. And then times 2 here, times 3. So this is also 6 times 3 and times 3. Alright, now what we want to do is we want to cancel anything that's the same on both sides so we don't have any redundancy. And it looks like the only thing that's going to be the same on both sides are my electrons, which always get canceled. You will never have electrons in your final reaction. Okay? So we've got Cr, 2Cr, OH, 3 there. And then we've got the other reactants. My water. And my BR. And then I want to write down all the products. Now, I told you there's going to be one little thing that's different here because we have this reaction occurring in a basic solution. The basic solution has hydroxides, has hydroxides available to us, but we have assumed that this is happening in an acidic solution. So we have to make a little correction. Notice we have H pluses here, but if it says basic solution, we can't have H pluses in our reaction. But we assume it's acidic, and now we're going to correct it. The way we correct it is we are going to neutralize all of those H pluses with the equal number of hydroxides. So anywhere you see H pluses, they only should be on one side if you've done it correctly. I'm going to add the same number of hydroxides. What that does is it turns all of that into water. And if I added 10 hydroxides on the right, then I have to add 10 hydroxides on the left. Now what that does is all of this right here, 10 H pluses and 10 hydroxides, turn into 10 waters. And then we look to simplify that with any waters on the other side. So notice there's 2 waters on the left. Those 2 are going to cancel 2 from here, leaving only 8. Okay? So that is your final reaction. Here, I'll just circle everything that should be in this final reaction for you. Those are your reactants, and then here are your products. And that's you would write that for your final reaction. Okay? So if you would take some time and do B. You should be able to do B, which is going to be very similar to the one that I just did. Okay? All right, let me know if you got questions, and I'll have the answers available to you so you can check your work. All right, keep up the good work.